explain you how to obtain a Luguerre function. So that is one of the special function. First what we have to do, we have to consider the Luguerre's differential equation. So here I have written the Luguerre's differential equation. Okay. It is given by the second order differential equation. It is x square d square y dx square plus 1 minus x dy by dx plus n y. You should always remember this equation, Luguerre's differential equation. With the help of that only you will obtain solution for that is Luguerre function. N is positive integer here, whatever the n is there. Solution of this equation is known as Luguerre function. As I said, in order to find out singular points and possibility of the series solution of this equation, we have to consider p of x 1 minus x divided by x. So here p of x we can consider 1 minus x divided by x. Q of x is n divided by x. Obviously there is a singular points at x equal to 0. If you put x equal to 0, singular points you will get. Singular point is regular as x minus 0 p of x and x of x minus 0 square q of x. Both are finite at the point x equal to 0. Thus, as per Fuchs theorem, Luguerre differential equation has a series solution. So series solution, always any of the special functions are having series solution. That is power series method we have to use to solve any of the special functions. So here Luguerre function also we can use power series method. Let us consider here, let the series solution be y equal to summation m equal to 0 to infinity am x to the power m plus k. A naught is not equal to 0. Equation 2. Let us consider it as equation 2. On differentiating equation 2, we will get dy by dx summation m equal to 0 to infinity am as it is x to the power m plus k. Differentiation of x to the power n. How we write? That is n into x to the power n minus 1. Differentiation of x to the power n. Here x to the power m plus k. So m plus k into x to the power m plus k minus 1. Differentiation. So once again we have to differentiate equation. Consider it as equation 3. Equation 3 if you differentiate d square y by dx square summation m equal to 0 to infinity am m plus k as it is. Again we have to differentiate like x to the power n. So m plus k minus 1 x to the power m plus k minus 2 we will get. Minus 1 that is minus 2. Equation, let us consider it as equation 4. Using equation 2, equation 3 and equation 4, we have to substitute them in equation 1. So here equation 1 consists of d square y by dx square dy by dx and y. All the three values we can substitute in equation 1. So we can write like this. First term is what? X into summation m am x plus am into m plus k minus 1 into x to the power m plus k minus 2. Second term is 1 minus x into summation m plus k. Like that you should substitute all the three values y dy by dx d square y by dx square in equation 1. You will finally get this equation. After substituting, let us make the coefficient of x to the power m minus k. one side. So after simplification we will get summation m equal m am into m plus k square x to the power m plus k minus 1 plus summation m am. What we have to do here, we have to consider am into n minus m minus k. Then we can write x to the power m plus k. Because here 1 minus x is there, we have to simplify the above equation. We will get two terms here. Let us consider it as equation 5. Equation 5 is here x is there. So once we simplify overall equation, you must get these two terms. Here x to the power 1 is there. If we equate, it will be x to the power m plus k minus 1. Okay. So here 1 minus x is there. Once you simplify, you will get this term. Equation 5 is polynomial equation and it can be satisfied only when coefficient of each power of x is equal to 0. Equating the coefficient of the lowest power of x, that is coefficient of x to the power k minus 1 to 0 we get. So x to the power k minus 1 coefficient we have to equate. Here x to the power m plus k minus 1 is there. Then only first term we can consider here by putting m equal to 0. We can get, if we put m equal to 0, first terms will be what, x to the power k minus 1 coefficient. So then a naught m equal to 0, if we put a naught here m equal to 0, that is k square, we will get this one. So a naught k square equal to 0. Second term we can't consider because it doesn't consist of coefficient of x to the power k minus 1. So from this a naught k square equal to 0, here a naught is not equal to 0, then therefore k is what, equal to 0. Equating the coefficient of x to the power r to 0, we get, since a naught is not equal to 0, a naught k square is equal to 0, therefore k equal to 0. Now equating the coefficient of x to the power r to 0, we get ar plus 1. A naught we have taken, r x to the power r coefficient, if you equate, you will get ar plus 1, r plus 1 plus k square from this term plus ar second term. Second term will become m equal to r, you can take ar n minus r minus k equal to 0. Then ar plus 1 equal to what, n minus r divided by r plus 1 square ar. So like once you get the general equation, put r equal to 1, 2, 3 and so on. You can get a1, a2, a3 values, ar. Last term will be ar. Final equation you will get minus 1 to the power r n factorial r factorial square divided by r factorial square n minus r factorial into a naught. So we have to put a naught equal to 1. Substituting equation 6 in equation 2, solution of Luguerre differential equation, we can denote it by, so equation 2 is what, y equal to summation m equal to 0 to infinity am x to the power m plus k. In this we have to put value of ar, that is am equal to r. Then that is given by the Luguerre differential equation solution, y equal to ln of x summation r equal to 0 to infinity minus 1 to the power r n factorial divided by r factorial square n minus r factorial x to the power r. So m plus k is there. So k equal to 0, m equal to r. If you put, we will get x to the power r. Then finally you can write the Luguerre function. Solution of the Luguerre differential equation is what? Luguerre function. So this is how you can obtain the solution for Luguerre differential equation. Since the argument of a factorial function cannot be negative number. Factorial term involved is n factorial, r factorial. They should not be negative numbers. Therefore, upper limit for r in summation is changed for infinity to n. R equal to 0 to infinity. Instead that we have taken n because factorial term should not be equal to negative. So how the variation of Luguerre function with value of x for n equal to 0, 1, 2, 3. 3 for 3 terms they have given the graphical representation. Here along x the numbers you can take x values 0, 0.1, 0.2 and so on. Here ln of x, y-axis. If we plot the graph, first L naught, n equal to 0. L naught of x is straight line. L1 of x is gradually decreasing. And again L2 of x is decreasing. So this is how you can obtain the values different special cases for ln of x. So L0 of x is equal to what? 1. L1 of x is 1 minus x. L2 of x and so on. You can check by Lesander's function. So this is how we can obtain the solution for Luguerre differential equation with the help of power series method. I hope this